Welcome to lesson 1.5. We have three main different things we're going to talk about in this lesson. The first one is rate of change, and this shouldn't be a new topic. We have two types of rate of change. The first one you should have learned in junior high. That is average rate of change. And that is your classic slope formula. Change of y over change of x. So that one should not be new. Instantaneous rate of change is the rate of change at a single point. Not over time, not like on average I went 60 miles an hour on the freeway to get to my mom's house. This is at 36 minutes into the ride, I was going 62 miles an hour. That's an instantaneous rate of change. This one we're not going to talk about as much right now. We're building up to what an instantaneous rate of change is, which is a derivative. So we'll come to that in the next unit. But let's review average rate of change right now. So change of y over change in x. Oops, there we go. So if I want to find the average rate of change, here's my x's. So I have x1 and x2. What I need to find are my y's. So I plug my x's in to find my y's. So I plug them into the equation. So this first one I get 8 minus 8 minus 10. So that's negative 10. This one I get 27 minus 18 minus 10, which should be negative 1. So this was my x1, this was my x2. When I plug them in, the answers I get are my y1 and my y2. And now I can just plug them into my equation. So y2 minus y1 all over x2 minus x1. Which I simplify to give me 9. Now, you might be wondering, what if I switch my y's and my x's? So if I did negative 10 minus negative 1 and 2 minus 3. Well, let's try it. That would be negative 10 plus 1 all over negative 1. Still equals 9. So it doesn't really matter which order the points go in. You just make sure that the right y goes with the right x. So that negative 10 goes with 2 in this equation. The negative 10 is on top of the 2, and the negative 1 is on top of the 3, because they're the pairs that go together. So pause the video, try out B. Ready, set, go. Okay, should have gotten 23. Now let's look at part C. Which of these is likely to be a better estimate of the instantaneous rate of change at x equals 2.4? So which do you think? 9 or 23? Which would be a better estimate of the rate of change at 2.4? Well, it would probably be 9. Because 2.4 is between 2 and 3. Not between 3 and 4, so the average rate of change between 3 and 4 isn't going to be as good of an estimate. Let's move on to number 2. This one is even easier than the last one. We want to find the average rate of change of the car on the final 2 hours of the trip. So here are my final 2 hours. So I want from x equals 2 to x equals 4. I don't even have to plug anything in this time because I already have my y values that go with those x values. So now I just need to plug them in. Just make sure that the right y goes with the right x. And if I simplify that, I would get 65. This is miles per hour. Miles on top, hours on bottom, so miles per hour. So on average, in the last 2 hours of this trip, I went 65 miles per hour. Now, here comes a tricky question. I want to estimate the instantaneous speed at 1.5 hours. So right here in the middle of these two, I want to estimate exactly how fast I was going at 1.5. Now, we don't have the math to know how fast you were going at 1.5 yet. So that's why we have to estimate. So the best way to estimate it would be to look on either side. So I'm going to estimate 1.5 by finding the average between 2 and 1. That gives me 65 miles per hour. So at 1.5, I was probably going somewhere close to 65 miles per hour because that's 1.5 is in between 1 and 2. Last one. During which hour does the data suggest the car reached the greatest instantaneous speed? So what I need to do is find the average rate of change between each of these intervals and then see which one is the greatest. So I'm going to have you pause the video. You're going to need to find change in y over change in x 4 times. So practice calculating that. Ready, set, go. Okay, let's look at what we got. Between 0 and 1 hour, I went an average of 55 miles per hour. Between 1 and 2 hours, I went an average of 65 miles per hour. Between 2 and 3 hours, I went an average of 60 miles per hour. And between 3 and 4 hours, I went an average of 70 miles per hour. So what would you estimate is where I went the fastest speed? Probably between 2 and 3 hours, because that's where I had the fastest average speed. So I probably went the fastest instantaneous speed somewhere during that time. So between hours 3 and 4. In the next video, we're going to talk about the squeeze theorem.